9702 March 2022 paper 2 variant 2, and the topic is energy work done, work power energy. Question number 2, part A, state what is meant by work done. The work done is the product of force and the displacement in the direction of applied force, right? A beach ball is released from a balcony at the top of a tall building. The ball falls initially from rest and reaches a constant velocity. The gravitational potential energy of the ball decreases by 60 joules as it falls from the balcony to the ground. The ball hits the ground with a speed of 16 meters per second and kinetic energy 23 joules. From this information, we understood at certain point the ball reaches the terminal velocity. So that means the acceleration due to gravity, which was initially 9.81, here in this point, acceleration becomes zero. And from that acceleration, the ball touches the ground with a speed of 16 meters per second. Okay, now here is the ball at point A, release from rest, right? Initial speed will be zero, and after certain point, its velocity becomes constant, and acceleration becomes zero, and then it touches the ground. And the next part of this information says the gravitational and potential energy of the ball decreases by 60. So as it touches the ground, the gravitational potential energy touches the ground. Before that, it was 60 joules decrease. So that means at the height, it was 60 joules. And that joule at certain height, it becomes 60 joule and 60 joule, and then when it touch and the kinetic energy becomes 23 joule. Here it is in 60 joule and it becomes 23 joule at point B. That means some energy loss, which is 60 minus 23. Okay, so show that the mass of the ball is 0.18 kilogram. Kinetic energy is half mv square, so 23 equals half m16 with the speed 16 square, which is mass becomes 0.0178, so approximately it is 0.18 kilogram. Part 2. Calculate the height of the balcony above the ground. So as it falls at before it touches the ground, so the potential energy is 60. So at the height it is 60. So 60 equals mg delta h. So delta h is the change in height that you need to calculate. So delta h equals 60.18 into 9.8, which is 34.01. So approximately it is 34 meter. So you need to think that this is the height where its height is 34, and here it was potential energy was uh, 60 joule, and then energy there after the energy loss at the bottom it becomes how much? 23 joules. Okay, so the last part, determine the average resistive force acting on the ball as it falls from the balcony to the ground. So total work done is actually what which is done by the air that responsible for the reduction of the energy. So total work done is equals to change in energy. Work done is equals to 60 minus 23 joules, that is 37. So friction, the work done by the air is 37 joules. So work done by the air is 37. Force applied by the air is F, and body displacement during the displacement of 34 meter. So 37 equals F into 34, then F becomes 1.088, means 1.1 meter, right? So the last part. The last part is variation, if any, in the magnitude of the acceleration of the ball in B during the time interval when the ball is moving downward before it reaches the ground. It is very clear that when the body start falling downward, there was no air resistance. So at that time, the acceleration due to gravity, which is g. But after after the time, acceleration start decreasing, and g become g until it becomes zero when the velocity becomes constant. That means the terminal velocity achieved. The resultant force started decreasing because F equals ma. So when the acceleration decreases, means the resultant force will also decrease. So resultant force decreases. Who is responsible for the reduction of force? It is actually the air resistance force. So the resultant force started decreasing due to the increasing of resistive force until it is equals to the weight of the ball and the body achieve its terminal velocity.